All right, welcome back, guys. So right now, what I want to do is I want to program the ball, and the ball is definitely the most complex object in our room. There's some things that can happen that can cause our ball to get lodged into objects, and sometimes if the ball is moving fast enough, if you're not careful, it can actually leave the room, and that's kind of a game breaker because a condition is never met that will reset the ball and let you continue playing. And so we got to make sure that we avoid that. So the first thing I need is I need a sprite. So I'm going to go create sprite, give it a name, SPR ball. I am going to shrink the canvas down to 32 by 32. I think that size works really well. And edit sprite. And I could really use any color here. I think I'm going to go with, let's see, probably should have decided this before shooting the video. I'm going to go with yellow. So I'm going to choose this option, which is to create just a filled in yellow ball as I drag. If for some reason it's oval, if I hold down shift, and then move my mouse, it gives me a perfectly symmetrical ball. I want to give this ball a little bit of artistic flair, so I'm going to go ahead and make it look shiny. That's way too big. Um, so I'm going to make it look shiny. Ooh, that's not what I wanted. Oh, it's still on the ball. I want to choose the brush. How silly of me. And then I also want to give it a little bit of shading, so I do have to freehand this. I'm going to go back to my yellow. Now this list of colors here are your canvas, are the colors that you've used recently. I'm going to drop down my value and shrink down my brush here. In fact, I just want it to be a point, and we'll give it a little bit of shadow there, fill that in. And again, not spending a ton of time because this isn't an art class, but not spending a ton of time on the ball, but I think that that's going to look okay. I got to create the ball as an object and give it a sprite. Now the ball is going to have some variables in the create event. We're going to probably add more later. But the first one I want to do is give it a speed. And again, for some reason, a lot of the YouTube experts in Game Maker don't use built-in variables. In fact, I'm going to give this an even better name. I'm going to call it start speed because our ball is going to speed up as we play the game. And it's going to have two states. It's either going to be in play or it's going to be not in play. And in play, by default, is going to be equal to false. And you'll see why in just a moment. So I'm going to add a step event. And the step event is essentially the main loop. It's where the behavior happens. Now I'm going to say if not, this exclamation mark means not. In play, we want the ball to do these things. Else, and there's only really one other condition, and that's in play, then it's going to do this stuff. And so all of our collisions and behaviors while the ball is moving are going to happen in here. And this is what's going to happen when the ball is first introduced to the game. So the first thing we're going to do is we're going to have the x equal the object bat.x. So it is going to follow the bat. So when we move the bat around, it's going to follow with it. Now I bet I forgot once again to center the ball, and so let me go ahead and do that. So by default, the balls is not going to be in play, and so it's just going to simply follow the ball. So or follow the bat. Let's see what that's going to look like. I'm going to go ahead and drag my ball, which I did not name. I've got to make sure it's on the instance layer. Um, so we're going to put it right there. And when we move the bat, we should also move the ball. So let's find out. And it does. It moves right along with it, and that's great. Um, not a very fun game yet, but it's great. So we want to be able to launch the ball with the space key. So I'm going to say if keyboard check VK space, then we want to do these things. and there'll be a series of things. The first thing we're going to do is give the ball a direction, and I want it to go up sort of like a cone like this, anywhere from 45 degrees to another 90 degrees. So the direction is going to equal 45 plus a random number up to another 90. So that's going to be its direction. If I want this to be truly randomized, I have to say randomized. Otherwise, it's always going to launch in the same direction once it determines that initial. We're going to go ahead and say speed equals start speed. And I didn't call it start speed. I called it start SPD. And then we're going to say motion set. And if you look down here, motion set requires 2 arguments, direction and speed. And lastly, it won't do anything unless we set in play to false. So true actually. So in play is now true. So it will skip this and then run this code in here. So right now, all that should happen is when we hit the space key, in play will become true. It'll randomize and then send the ball in a random direction, set the speed to start speed, and then, well, let's see. So I'm going to go ahead and run the game. In play is false until I hit the space key, and it chooses a random direction. Unfortunately, we don't have any collisions in our room, so it goes right off the screen. So that's the next thing we're going to do. So as our ball starts to speed up, let's just say that it's 1 pixel or 2 pixels away from the wall, but its speed is 8. That means that 6 pixels of the ball would go into the wall, and that can lead to some problems. The ball can either get lodged in the wall or sometimes just leave the room. So what we're going to do is we're going to sort of look ahead. We're going to say, okay, in this frame, is the ball going to overlap the wall? And if it is, we're going to very quickly and deliberately move it until it's 1 pixel away from the wall, and then stop it there before changing directions. So collision in code is if place meeting x, y, and then the last argument you see down here is the object. And in this case, we want to check for an object with the boundary. Then we're going to do this stuff. And again, we actually are going to be anticipating a collision. So I'm going to say x plus h speed. Now, h speed, if you don't remember, horizontal speed is negative when it goes to the left and positive when it goes to the right. So this could be x minus h speed if it's a negative number. Really determines if the ball is moving to the left or right. And now I'm gonna, if it's going to collide in this frame, I'm going to run a loop, and I'm going to use a while loop. So while not place meeting, and then in this argument, which is going to be a little bit confusing, but just bear with me, x plus sine h speed. Now, if you put the word sine in front of parentheses, it is going to determine whether or not this value is negative or positive. So it's going to become either a -1 or a +1. Now, it is possible that it could be a 0, and 0 is neither negative or positive, but that won't, if the h speed is 0, it is not going to run into a wall on the left or right. So it's going to, while it is not 1 pixel away from the wall, which is essentially what that's saying, object boundary. So while that is happening, we are going to move the ball 1 pixel closer to the wall. So while this is going to happen, we know there's a collision in this frame, it is going to move it 1 pixel at a time very quickly. You won't see it because loops happen at incredibly fast speeds. It is going to move 1 pixel, either negative to the left or positive to the right, towards that wall. Now, when this is no longer necessary, then what we're going to do is we're going to change the h speed. So this is going to happen. If this is no longer happening, then h speed is going to times equals -1. So it's basically going to change the sign of h speed. So if h speed is negative going to the left, it's going to hit that left wall, and then h speed is going to become positive and move towards the right. So that's what that all does. Then we're going to go ahead and copy, paste, and now we're going to set up collisions with the top of the room, because there is no boundary at the bottom. So if there's going to be a collision at the current v speed, vertical speed, with the boundary, while it is not 1 pixel away, so get rid of that, y plus sine, whoop, I accidentally hit the sine v speed, then y is going to be plus equals sine of v speed. So copy and pasting is a real time saver. And when this is no longer happening, then it's going to change the v speed to whatever sign it wasn't already. So I may be missing a step here. Let's find out. So I'm going to go ahead and play. I may have to set that up differently, but let's find out. So it's not launching the ball. So that tells me I've got something slightly out of order. So I'm going to go ahead and pause the videos and get that fixed, and then I'll come back and tell you what I did. So, all right, I'm back. So I just had to rearrange some things. So, excuse me. The things inside of this loop would happen inside this begin of block, end of block bracket, and then when this whole while statement was no longer needed because it was in fact 1 pixel away, then it could move on to the next command, which was to change its h speed and v speed. So I just had to rearrange my nesting of my commands a little bit, and to make sure that that was all going to happen. So currently, when I launch the ball, it does choose a random direction, and when it hits the horizontal wall, it bounces, but you can see I don't yet have a collision with my paddle. But I do have pixel perfect collisions here. So again, if there's going to be a collision this frame at its current horizontal speed, then this loop right here moves that ball one pixel at a time until it is 1 pixel away from the wall. And then when that happens, so this keeps happening while it's not 1 pixel away. Once it is 1 pixel away, it then will skip down to this step where it changes the direction. This works really well in platformers as well. So the very last thing I need to do is have a collision with the bat. So if place meeting at XY object bat. Um, I want to be able to have some control over where the ball goes. So I'm going to say that when the ball hits on the left side of the paddle, I want it to bounce back towards the left, and when the ball hits the right side of the paddle, it will bounce to the right, and if it hits dead center, then it would head straight back up. That's typically how breakout works, and to do that, we need to get a direction. So I'm going to create a temporary variable of direction, and I don't I did use that up here. I guess I could have set that up as a temporary variable as well. Um, so direction is going to equal point direction, which draws a line between 2 places. And where I want it to draw a line is between the object bat's origin and its own origin. And I may have this backwards. We'll find out in a minute. when it does something all kinds of crazy. I do want the speed to increase slightly, so I'm going to have it get a little bit faster. So by I'm going to say 0.25, but I may decide to temper that back later. Because my plan is that I want the game to become more challenging. The more you have to hit the ball, so you actually benefit from hitting the ball with the paddle the least amount of times. And then once this is determined, then um, we'll say motion set, DIR, speed, and so that should set the ball in that direction. So let's find out. Sometimes you have to just give it a whirl and see if it does what you expect. So I want to be able to control the ball, so it should bounce to the left. Yeah, it did perfectly. When I hit the ball to the right of the paddle, I want it to move to the right. And then if I'm lucky enough to hit it dead center, I want it to move straight, a little more straight up. So that all is working really well. So we can keep the ball in the room. The ball doesn't become lodged with the wall, which is good, and it is a threat when the ball starts to speed up. And things are working pretty well here. I can control what direction the ball goes in to some extent, and so that's good. Now I don't have anything that happens when the ball goes off the screen, so maybe I can do that real quick. And and that is, of course, to say if, so again, I'm in the ball object, if y is the y is the up and down is greater than room height plus 16, so that means the ball would be completely out of the room, then we're going to do these things. And so for now, we're going to say that in play is going to equal false. So that means that it's then going to do in play the next frame. It's going to do these things. I do need to move to the ball in position. So I'm going to say y is going to equal object bat y minus, um, let's see, I forget how big the bat is, 32. So 16 plus 16, so I'm going to say 33. So that means the center of the ball is, because I want the ball to sit just over the bat. So I think that might work. And then I've got to set um, let's see, I don't have the speed set here. So I guess I will want to say the speed equals 0 and direction. Um, I guess the speed equals 0. I won't really need a direction. Now, eventually, when I add lives, I'm going to want that to happen here too. But this video is getting a little bit longer, so I just think I want to end here with the ball going off the screen. Oh my God, I missed. And it sets it right on the paddle, ready to be launched again. Beautiful. All right, so there's a lot there. Um, uh, that really all you need to know is that this coating was set up so that the ball never overlapped the wall, wouldn't become lodged in the wall, and actually, when there's a collision, it is literally 1 pixel away. It's really set up nicely. And then here we were able to use a point direction to create the new direction of the ball, drawing a line between this origin of the bat to the ball. So if the bat is here and so slightly to the right of the ball, it would take that center point, find this center point, and that's going to be the direction of the ball. So good stuff. Thanks for watching. I'll see you in the next video.